Hey, y'all, this is the last section of review number 3, and we're going to talk about solving, finding zeros, finding x-intercepts, and factoring quadratics. And a lot of that stuff is the same process. So we talked in class that's roots, solutions, and zeros are all the same thing. And we can find all of those by looking at x-intercepts. So if we're looking at this first page, I graphed it on my Desmos because it might be a little fuzzy on the screen, but you can see it on your paper, that if we want to solve a quadratic function or a quadratic equation, we can put it into Desmos, and then the solutions will be located at the x-intercepts. So we'll go find those x-intercepts, and I can highlight them here. We're solving for x. When we look at the coordinates of an intercept, the first number represents the x value. And so our solutions are -3 and +3. And we could solve any quadratic function by doing this, going and finding the x-intercepts and then picking out the x value. So you can see that they put it in set notation here, -3, +3. We can find the zeros and the roots the same way because they are the same thing. So if we look at this function, x squared minus 4x minus 12, we would go find the x-intercepts right here. I'll write them a little bigger. They're on your paper. The solutions to this function are -2 and +6. The roots of this function are -2 and +6. The zeros of this function are -2 and +6. So those are, remember, 3 words that mean the same thing. We find them by taking the x number from our intercept. We're also able to make these things turn into factors, the two things that multiply together to make the quadratic function. We would write them like this, our solutions, and then we would unsolve them. So we would do the opposite of what we did at the beginning of the year when we were solving equations. We're going to go ahead and try and get uh, the number over on the same side as the letter. And so we would move -2 over, and it would become +2. We'd move the +6 over, and it would become -6. And then we put some parentheses around them, and we have factors. It's a good idea when you're factoring something, if you're looking for factors, to graph the original quadratic and then graph the factors to make sure they lay right on top of each other, and then you know you have the right answer. More on that in the next example. So we want to factor this one. So I'm going to put it into Desmos. You should as well. You should practice this with me so you can see it right in front of you. We can go find the roots, solutions, and zeros. They're right there. Those are the root solutions and zeros, -0.667 and +5. We're going to want to change that -0.667 to a fraction. Whenever you have 0.667, that comes from rounding a decimal that had a lot of sixes. So we just fill that up with sixes, and we find that it's -2/3. So our roots, solutions, and zeros are x equals -2/3 and x equals +5. In order to find the factors, we unsolve. So to unsolve this one, we're going to move that +5 over, and it's going to become x minus 5. So we can go ahead and look, click that one. That's one of our factors. To unsolve x equals -2/3, we have to do a little bit more. 3 is dividing on the right side, so when we move it over, it's going to be multiplying the x. And then we have the -2 that comes over and becomes +2. And so then we have one of our other factors. I said it's a good idea to graph the factors. So in parentheses, I'm going to type 3x plus 2 and then x minus 5 on the same line in Desmos. And you can see that my new graph doesn't quite overlap the old one. They have the same intercepts, which means we're on the right track, but it's not perfectly fitting. And that's because there was a common factor. We found common factors not too long ago. And that common factor is usually just a number. And so we have two options here, 3 or 9, and I can just go put them in there. 3, let's test 9. You can see 9, they don't overlap. When I type 3 in, they do overlap. So we have one more factor that we would have to find here. If this is a little fuzzy for you, you can always reference the video from not too long ago on factoring. So anytime we're looking for roots, solutions, zeros, factors, the thing we need to do is we need to graph the function. And then we're going to go locate the x-intercepts. You might want to zoom in if you can't see them right away. We have -1 and -1.5. We should always take those decimals and convert them to fractions. So really we have -1 and -3/2, and we can choose that as our answer. Sometimes we might need to know about domain and range, and this is from a long, long time ago. But domain is all of the possible x values of a function. So how far to the left does it go? How far to the right does it go? The range is how far up and down it goes. So if I look at this one that we just did, it's not the same as this one over here. These parts of the curve are going to go to the right forever and to the left forever. So we would say that the domain is all real numbers. And that's what it says about this function as well. The domain is all real numbers. That means going to keep going left and right forever. The range is how high or low it goes. Well, this one goes up forever, but it doesn't go down forever. It stops here. This would be part of our range. And we look at our y and we say that, okay, well, we can have y values that are greater than or equal to -0.125. So let me actually type this example in there. And remember that if you ever have the house over here, you should click it because it's going to zoom and fit this screen. I'm going to go find that point. That's as low as this thing will go. All of the points are going to be above this. Above would mean greater. If it was flipped the other way, upside down, then all the y values would be below this point, less than. But as it is, they're all going to be above this point, 2, 3. 2 tells us how far we are to the left or right. That's not what we're looking for when we talk about range. Range tells us how far do we go up and down. Well, this point is 3 in the y direction, and all of the other values are going to be above it. So that means all of our points are going to be greater than or equal to 3. Please make sure, as I say in all the other videos, that you are pausing and asking for help if you need it. There's a few examples. I might just have you try this one on your own and then ask for help if you need it. If we're looking for which of these functions has exactly 1, 0, we're looking for which of those only crosses the x-axis one time. So much like we did in a previous lesson, you could graph them all and figure out which ones cross the x-axis once. If it crosses twice, that doesn't count. If it doesn't cross at all, that doesn't count. So like this one has no zeros because it doesn't cross the x-axis. So you should try this one on your own, and you can check your answer and ask for help if you need it. Similar here, we're going to graph these, and we are going to find the solutions, which is where do they cross the x-axis, and then what are the x values there. So we're crossing at -3 and 1. The way they present this problem is slightly different. You actually have to type your answer in. So we would type in -3 and 1. And then on this last one, we're looking for solutions. Um, we don't have to get hung up on what is a real solution. We're looking to see how many places do each of these cross the x-axis. If they cross the x-axis in one place, you would click that button. If it crossed in two places, you would click that button. And if it didn't cross the x-axis at all, you would say there are no solutions. And you would do that for each of these and click the appropriate button. So I would say you should try this one on your own. We're just graphing each of them and figuring out how many solutions each of them have. Again, you should check your answer with the answer key. And then once you're done with that one, this is the end of this final lesson of review number 3. There are some more practice problems for you to do. You should definitely check the answer key. You should ask if you get a wrong answer or you get stuck, and take your time. Good luck.